Hey guys, if you're in calculus, this is from 3.2, and if you're in pre-cal and we are learning calculus at the end of the year, this is from 4.3. We're going to be going over two theorems out of the 6 that are in calculus. These are very popular in the AP questions, especially at the end in the free response questions. I do have you guys memorize them, and in calculus we do take quizzes on them, okay? So the first one we're going to go over is Rolle's theorem and then mean value theorem. I'm going to give you the theorems with an if and then statement and then an image. In the textbook, you're going to see it more like a full sentence, okay? I just think it's a little easier to break down like this. So Rolle's theorem states, if f is continuous on the closed interval, differentiable on the open, and f of a equals f of b, then there's at least one number c in a and b such that f prime of c equals 0. So let's talk about what each of these mean. First, that it's continuous, meaning drawing your function from a to b, you don't lift your pencil, no holes, jumps, or asymptotes. Differentiable means that the same thing as continuous, but it adds that it cannot have a sharp turn. Okay? And then f of a equaling f of b, meaning that the y values of the endpoints are the same. Okay? And then there's going to be some number c in between, that f prime of c equals 0. Remember that f prime of c equals 0 is how we would find our extremas in our last lesson. So this is saying that as long as these three are true, we have 100% proof that we're going to have an extrema, whether it be a max or a min. So whenever you solve these problems, you're first going to prove the three ifs, then you know for sure you're going to have an extrema, and then go ahead and solve for that extrema. Let's take a look at our first question. It says, show that f prime of x equals 0 for f of x on the interval from 1 to 2. Well, to start off with, f of x, the highest exponent is an x squared. So automatically, I know that f of x is a parabola. Specifically, a parabola facing upward, because that first term x squared is positive. Okay? Now, I know that parabolas are always continuous and differentiable, so I just proved my first if. By the way, those 3 dots in a triangle is a math symbol for the word therefore. Feel free to use it, okay? Now, I want to prove that f of a, so here's my a, 1, and my b is 2. I want to prove that they're the same. So I need to take a moment and solve for f of a, which is f of 1, and f of b, which is 2. And I just do that by plugging it into the function that was given. And when you clean these both up, they both end up giving you 0. So check mark, f of 1 is equivalent to f of 2. So I proved it was continuous, I proved it was differentiable, and I proved that the y's were the same. So I can say, therefore, and I want you to get used to writing these sentences the way I write it. It's that typical easy, clean way that the AP test expects it. So it's a good habit to create, okay? Therefore, by Rolle's theorem, there is an extrema. We're just rewriting the theorem. For f of x in the interval of 1 to 2. Okay? Now, some questions on the AP may just ask you to prove that. Some may ask you to finish and actually find what that extrema is. So just for the sake of practice, let's go on to the first derivative test. And let's find what that extrema is. And we'll be able to prove further that there is going to be an extrema in between 1 and 2. That means the number I'm going to get for my max or min is going to be somewhere in between 1 and 2. First derivative test says to start by doing the derivative of the function. set it equal to 0. And I have a critical number of 3/2, which is 1.5. So this is starting to look like it's on the right track because 1.5 is in between 1 and 2. Okay. Actually, that does equal, so let's not put an approximation symbol. I'm sorry. All right, let's do our number line. Remember, our number line is closed off from 1 to 2. And I'm going to put my 1.5 right in here. Let's test some numbers in between. Let's say 1.25 on the left. And then let's say 1.75 on the right here. If I put 1.25 times 2 and then minus 3, I am going to end up with a negative. And if I put a 1.75 times 2 and then subtract 3, I'm going to get a positive. So negative indicates decreasing and positive indicates increasing. So there is my proof that I did have an extrema, specifically a minimum, at 1.5 or 3/2, and it did end up being in between 1 and 2. Let's check out another one of these. So for this next question, it says, find the value of c in -4 to 4 such that f prime of x equals 0 for f of x. Okay, so we know that they're stating here Rolle's theorem based on them asking us for the extrema, and they're giving us the interval and to find that number in between that justifies that. So we start off by checking if it's continuous. Because this is a rational function, I know that rational functions always have a discontinuity when the denominator equals 0. So I'll start off by saying that f of x is discontinuous when the denominator, which is -x plus 5, equals 0. If I subtract the 5 over, I get -5, and then divide the negative, I can say that x is discontinuous when it equals 5. Okay? Now, if we look at the interval, they want us to look only between -4 and 4. So the problem area that I have is not even within the area that they want me to look at, so we could say it's okay. I can then go on to say that f of x is continuous in its interval from -4 to 4. And because rational functions don't have any sharp turns, those happen with absolute values, I can also say that it's going to be differentiable. So I just checked off 2 of the 3 requirements. My next requirement is checking that f of a and f of b equal the same thing. So let's check them out. F of -4 and f of 4. Let's plug in that -4. Feel free to do this off the top of your head or on your calculator. This gives me -16 plus 16, so I have 0 over, and then this gives me 4 plus 5, so this gives me 9. 0 over anything is 0. Now I'm plugging in the 4. And this again gives me -16 plus 16, which is 0. Over this gives me 1, which 0 over anything is 0. So, check mark, they both gave me the same answer, and I can say that f of -4 is equal to f of 4. So based off of those 3 things I just proved, that it's continuous, differentiable, and f of a equals f of b, I can now state by Rolle's theorem that I will have an extrema. So let's write that sentence really quick. Very important for FRQs in an AP class. Therefore, by Rolle's theorem, there is an extrema for f of x within its interval. All right, so we finished proving Rolle's theorem. I'm going to go ahead and take the extra step and actually find what that extrema is for practice. We do that by completing the first derivative test. So I'm going to say first derivative quotient rule is low d high derivative of the top minus high d low derivative of the bottom over low squared. Okay, let's clean out that numerator. We're going to distribute here, and then here we're going to distribute this negative and this negative 1. So here we distributed this side. Now the two negatives, this is going to end up being negative x squared plus 16. Remember, there's no need to clean the denominator. And I'm going to combine like terms and clean one last time. All right, so now that I've cleaned up my derivative, I'm going to set it equal to 0 or undefined. The way I set it equal to 0 is by setting the numerator equal to 0, oops, which this I can factor. I need two numbers that multiply to give me 16, but combine to give me a negative 10. So I can use a negative 2 and a negative 8. So here x equals 2 and 8. Now from those two, I remember I need to go back and look at what my interval was. My interval is from negative 4 to 4. Okay? 2 fits in between there, but 8 does not. Okay? So we're going to skip this one because of the interval being from negative 4 to 4. And right now we're only going to take this one. Okay. Now, being undefined is when the denominator equals 0. So I'm going to square root both sides to get rid of this squared. Square root of 0 is still 0. And then I could move that x over, and then I have x equals 5. Or you can move the 5 and then the negative. Now, one more time, check your interval. I'm looking from negative 4 to 4. 5 does not land in that either. So here's another one that we're going to skip because of the interval being from negative 4 to 4. Okay? So now my next step is to create my number line. Remember, this does have a closed interval from negative 4 to 4. The only of the three numbers that we found that fits in there is 2. Okay, I'm going to test an easy number before, which would be 0. And then I'll test an easy number after, which would be 3. If you would have picked here 1 or negative 1, same thing. I just like 0 because it cancels out easily. So if I put a 0 in here, this term cancels, this term cancels, and I have a positive 16, positive divided by, And then remember my denominator, if the entire thing ends up being raised to an even powers always give you a positive number. So no matter what I plug in here, I will always be dividing by a positive. So for this first one, positive divided by positive is positive, which indicates increasing. And then if I put a 3 in here, 3 squared is 9, minus 10 times 3 is 30. 9 minus 30 is already, let's say, negative 20 something, plus 16, I'll still state negative. Okay? And the negative divided by positive is negative, which indicates decreasing. So there you go. I just proved my max that I did have some number c, which in this case was 2, in between -4 and 4, where f prime of x equals 0. Okay, I found my extrema, which is 2.